Let's run through one more example. It's pretty lengthy, but it'll give you a good idea on how to use the angle-angle similarity theorem. But you want to use this diagram to complete each statement. Here's what I'm going to do. Just start going through and marking things down in the diagram that we can find. So if you look at triangle ABG, you're given two angles, which means you could always find the third. You could subtract 90 and 63 away from 180, or you can just subtract 63 from 90 to get this angle. Angle AGB is 27 degrees. These two angles, EGD and AGB, are vertical angles, so EGD would be 27 degrees. You can use the triangle angle sum theorem to find the measure of angle EDG as well. That would be 63 degrees. These angles would be right angles as well. Without being given either of these angles or either of these angles, you wouldn't be able to find these using the triangle angle sum theorem or vertical angles theorem, or without knowing that AC is parallel to FD. But this is kind of getting a little bit ahead of ourselves. These two sides are in proportion to these two sides. If this is 3, this would be 1.5. This would be 1.5 as well. So the two triangles would actually be similar. These two triangles, actually all 4 of the triangles in the diagram, would be similar by side angle side similarity. So that's kind of getting a little bit ahead of ourselves. But we actually need to know that to be able to find the measure of angle BCG, which would be congruent with this angle at 63 degrees. This would be 27 degrees. This right here, if you can see, would also be 27 degrees because of the vertical angles congruence theorem. And this is 63 degrees. So trying to fill in the missing information, angle AGB I have in the diagram is 27 degrees. Angle EGD right here is also 27 degrees. Angle BCG is 63 degrees. AG, that side length, we could use a proportion in order to find it. I'm going to let that be X. This side right here, BG, corresponds with GE. These two triangles are similar by angle-angle similarity. So 6 over 3 is equal to, I could let that be X over this side length right here, the hypotenuse. We actually need to find that first. This right here, as I mentioned, I'm going to draw this out so you can see it better. Triangle GED, this is 3. ED is 1.5. And you could use the Pythagorean theorem in order to find the side length GD. So 3 squared plus 1.5 squared is equal to GD squared. I'm going to let that be Y. So Y squared. 3 squared, 9. 1.5 squared, 2.25 is equal to Y squared. So if I add those together, 11.25, and then take the square root of that, that'll give me the value of Y. So then Y is about 3.35. And then that side corresponds with X, the hypotenuse in this right triangle, so about 3.35. And then I can cross multiply 6 by 3.35 and then divide by 3 in order to come up with the value of X. So the value of X should be about 6.7. X, I let be the side length of AG, so that's about 6.7. AB right here, I could set up a proportion as well. Or if you notice, if this is 3, this is 6. The scale factor would be either 1 to 2, actually going this way, 1 to 2, or 2 to 1. So if this side length ED is 1.5, then AB should be 3. EF should be congruent to ED, so that's about 1.5, not about, it actually is 1.5. ED, also 1.5. GF, where's that at? So GF should be congruent to GD. If you remember, this is GD right here, about 3.35. And lastly, triangle AGC is similar to, it would be triangle either DGF or triangle FGD. Either one would work.